Welcome to the College of Science Information session. We appreciate you taking the time to learn more about the exciting opportunities within the College of Science. My name is Colin Stout. I'm the program coordinator within the Office of Recruitment and Engagement. Today we will cover the different College of Science majors, academic advising, and then student engagement opportunities within the College of Science. Within the college, our 19 majors can be split into 5 different disciplines, which are as follows: neural, cognitive, and behavioral sciences, life sciences, physics and space sciences, earth sciences, and mathematics and computational sciences. We're going to take you through each discipline and the majors within them. In the neural, cognitive, and behavioral sciences discipline, we have 4 majors: neuroscience and cognitive science, psychology, psychological sciences, and speech language and hearing sciences. The neuroscience and cognitive science major focuses on the brain and the mind. It's an intensely interdisciplinary program because progress on understanding how the nervous system works will require collaboration and multiple perspectives. Our students are broadly engaged in laboratory research, in outreach to the public, and in volunteer service. The Neuroscience and Cognitive Science program is designed on a strong foundation in the basic sciences, in psychology, in philosophy, and in mathematics. This foundation is followed by a substantial set of core courses that expose students to the breadth and concepts and methods of scientific inquiry in the highly interdisciplinary fields of neuroscience and cognitive science. There are 2 psychology majors in the College of Science. The first, psychology, gives a robust and thorough psychology foundation and aims to prepare students to enter the workforce and apply the principles of psychology to their given career. Almost 50% of our students go into psychology-related or professional graduate schools, and the rest go right into the job market in areas such as human services, business, or education. This program mainly emphasizes the fundamental principles of psychology that can be applied to solve practical problems related to human behavior and society. The psychological sciences major provides the same robust psychology education while also integrating more math and science courses into the curriculum. The program prepares students for careers that require an in-depth understanding of the research methods used to study the mind, brain, and behavior. This program emphasizes critical thinking, analytical thinking, and quantitative skills that prepare students for a PhD program in psychology or for other advanced training programs that require a strong background in science, such as medicine, nursing, public health, education, business, or public policy. Lastly, we have speech, language, and hearing sciences. This program focuses on human communications and its disorders. It combines biology, acoustics, psychology, development, linguistics, and cultural foundations. This program is designed to provide foundational information to develop critical thinking skills, the ability to evaluate scientific information, and to facilitate the development of writing skills. The degree provides a strong foundation for students who wish to go on to be speech pathologists and audiologists. We have an on-campus speech, language, and hearing clinic where undergraduate students can observe therapy services for people with communication disorders, and there are also many opportunities to work with our faculty on research projects in areas of interest as undergraduates and as graduate students. Next, we'll discuss the life sciences discipline, which houses 5 different majors. The first of which being biochemistry. This major uses chemistry as a tool to examine and explore the processes of life. Biochemical and chemical knowledge provides an underpinning for many disciplines, including medicine, agriculture, and engineering. The questions that biochemists and chemists address encompass many critical challenges that face humans today. The next major is biology, which is definitely a popular major within our college. The biology major has 2 distinct concentrations, which are organismal biology and medical sciences. Students who wish to study purely biology, perhaps go on to graduate school for biology, or even become a professional biological researcher, would study organismal biology. Students interested in going to medical school or another health professions program would find that the medical sciences concentration is suitable for them. As a whole, the biology major provides a broad background in modern biology and offers extensive training in the structure, function, and evolution of biological systems. Students who choose the chemistry major will study the reactions that take place in the world around us. Chemistry is often considered the fundamental science, as it provides the connection between mathematics and the physical, life, and applied sciences. Students will study molecules and their transformations, as well as the composition, properties, and reactivity of matter. Students in chemistry have many opportunities to study science and get valuable scientific research experience, including summer internships, the undergraduate biology research program, and the biology, engineering, chemistry undergraduate research conference. The ecology and evolutionary biology program deals with the integration of biological systems across all levels of organization, from molecules within cells up through global ecosystems. As such, the department covers a wide range of topics, from the genetic analysis of complex traits, evolution at the molecular level, phylogenetic analysis, organismal form and function, population and community, ecology, genomics, and mathematical modeling. The University of Arizona is actually the birthplace of this major. We're number one in environmental sciences and number two in the world due to research and internships offered at Biosphere 2. Lastly, in molecular and cellular biology, students learn cutting-edge biology through innovative teaching methods and hands-on research experiences. The MCB major looks at life at a micro and macro level. MCB majors often become doctors, researchers, health professions, genetic counselors, attorneys, science writers, teachers, and more. There are many relevant and interesting classes on topics such as cancer, Alzheimer's disease, and other diseases that occur as a result of things going wrong in cells, molecules, and genes within the body. The next discipline we'll discuss is the Physics and Space Sciences discipline, which houses applied physics, and astronomy majors. In applied physics, students receive a strong physics foundation and learn how to apply those principles to the workforce. It's really designed for students interested in real-world problem solving. This is an ideal major for students aiming for careers in engineering, data science, public policy, medicine, or other sectors where a broad physics knowledge is integrated into complex, multidisciplinary problem solving. Astronomy at the College of Science is one of the premier astronomy programs in the country. The university has been a part of every NASA mission since its inception, most notably serving as leads on the Phoenix Mars mission and recently the OSIRIS-REx mission. The astronomy program encourages and provides undergraduate participation in research. We have telescopes within driving distance, which are easy to visit, offering undergrads the opportunity to work at frontline telescopes. And then there's many observatories where astronomers often visit, exposing students to innovative research, scientific talks, discussion from the world's leading experts. Lastly, the physics program will prepare the students to be creative thinkers and problem solvers who can be successful in any challenging field. The objective of physics is to discover the basic components of matter and the nature of the physical world, and to formulate a mathematical description of the laws that govern their behavior. Physics particularly places emphasis on research and requires it of its undergraduates. Next, we'll discuss the Earth Sciences discipline, which houses geosciences and hydrology and atmospheric sciences. In geosciences, this major studies the Earth from its core to the highest mountains and from its thousands of different minerals to its interactions with the rest of our solar system. The Geosciences program offers tracks that focus on fieldwork or even lab-based coursework. University of Arizona Geosciences students and faculty are involved in everything from predicting earthquakes to finding and extracting minerals from mines to monitoring coral reefs. Geosciences has its own faculty-led study abroad program called Accessible Earth, which goes to Orvieto, Italy to study Earth data collection systems. The department also holds something called Geo Days, which is an opportunity for undergraduate students to network with graduate students, faculty members, donors, and prominent alumni to get feedback on their research. Next is Hydrology and Atmospheric Sciences. This major provides students with a fundamental knowledge of the water cycle, from below Earth's surface to above Earth's surface, in both theory and application. We're number one in the nation for study of water resources. There's two subplans in this major, environmental hydrology and water resources, and atmospheric sciences. In environmental hydrology, this prepares students to solve practical hydrological problems related to drought, flooding, and water quality. And in atmospheric sciences, students will focus on various weather, climate, and hydrometeorological phenomena that impact our daily lives, property, businesses, military operations, and even our physical and mental health. And lastly, we have the Mathematics and Computational Sciences discipline. There are four majors within this discipline. First, there is bioinformatics, Bioinformatics aims to apply computational techniques to manage, analyze, and understand biological information. Bioinformatics is, put simply, the marriage of biology and computer science. Bioinformatics majors will be prepared to meet the growing demand for individuals who understand core biological concepts and the computational approaches needed for 21st century biology. Next is computer science. And in computer science, students will learn the fundamentals of developing, deploying, and maintaining applications for business and industry. Students will learn to develop computational systems, apply mathematical methodologies to solve computational tasks, and understand the structure and functioning of software systems. The computer science program has its own career center in the department with a dedicated professional whose job it is to help students find and prepare for internships and careers. The program is incredibly internship focused, having students complete multiple internships throughout their time. And often companies like Microsoft and Google come to campus to recruit and network with current students. The mathematics major provides a fundamental foundation of mathematics for students and allows students to choose from 6 different concentrations. Students can focus on applied math, comprehensive math, computer science, economics and business, education, life sciences, and probability and statistics. And lastly, we have statistics and data sciences. This major is relatively new to the college, and by merging modern data science approaches with a solid mathematical background and practical training, statistics and data sciences provides a curriculum that allows students to make significant contributions at the forefront of knowledge across the vast array of activities in government, education, and industry that rely on statistical thinking. Students can enter the workforce in market or scientific research, risk analysis, finance, analytics, or actuarial sciences. So those are the majors in the College of Science. And next, I want to talk to you a little bit about pre-med or pre-health. We know a lot of our students plan on entering medical or health professions school post-graduation. In fact, 42% of all science freshmen indicate they're pre-med. The great thing about being pre-med is that you don't have to choose a specific major to go into med school. You can choose any major that interests you and just build in the prerequisites for med school. The University of Arizona offers the Pre-Health Advising Office, which is dedicated to assisting students who are planning on going to medical or health professions school. Your pre-health advisor, your academic advisor, and you will work together to learn how to satisfy med school requirements within the framework of your existing major. And since we have so many students interested in being pre-med, we wanted to spend a little time discussing the requirements for medical school. In general, the following courses are required for medical school: general chemistry, organic chemistry, biochemistry, biology, physics, anatomy and physiology, English, psychology, sociology, college-level math, and biostatistics. In addition, the University of Arizona College of Medicine also requires 2 semesters of physiology, 2 semesters of biochemistry, an upper division molecular biology course, a social and behavioral science course, which could be psychology or sociology, a statistics course, and then an upper division course of one of the following: cell biology, histology, microbiology, pharmacology, pathology, or immunobiology. So next up, we're going to discuss an important component of academic life for students, which is academic advising. Academic advisors are dedicated professionals that serve as academic consultants to students. And what they do is they interpret policies and procedures. They can guide you towards personally relevant campus services and resources, help you make sense of this new learning environment, present options to help you make your decisions, and they can help you develop a plan unique to your goals. Your academic advisor will be your biggest asset in your time here at the College of Science. You have a dedicated professional whose main job is to work with you to create a plan, to find curricular and co-curricular opportunities that meets your needs and gets you to graduation with success and as much experience as possible. Make sure to connect with your academic advisor early on in your time here and build a relationship with them. Our advisors often go on to write recommendations for our students and serve as references. So build a relationship and you never know what could happen. They could turn out to be your biggest ally in your time here at college. This is a great quote from one of our academic advisors, David McQuiggan, who's in the Ecology and Evolutionary Biology department. David says that you are not just another number to your advisor. We're here for you. And this is so true for each and every one of our advisors. They do their absolute best day in and day out to get to know every student in their caseload and make sure to learn as much about them as they can so they can meet their needs. So get to know your academic advisors once you get here. They can serve as a wealth of knowledge for you. This last segment of the presentation is going to focus on student engagement opportunities within the College of Science. The College of Science is dedicated to providing a plethora of opportunities for our students to build upon their academic coursework and round out their time here at college. The College of Science combines professional development opportunities and research to help prepare you for your career. If you think about it, you only spend between 15 and 18 hours in class per week. And we at the College of Science want to help you maximize the time you have outside of the classroom to make sure you get the most out of your time. So when it comes to student engagement, there are four outcomes the College of Science wants you to get out of your extracurriculars. We want you to discover your interests, to learn by doing, to develop practical skills, and to be able to speak to those experiences. The opportunities for engagement are plentiful. You could partake in one of the 50 plus clubs related to the College of Science and network with other students who share your interests. You could get involved in outreach initiatives and bring the wonders of science to the community, like volunteering for Science City and the Tucson Festival of Books. You could be a peer advisor, which are upperclassmen who essentially onboard underclassmen into the college by mentoring them. Or you could even be a course preceptor, which is similar to a teaching assistant, and you can help faculty members deliver learning in a course you've previously taken. There's a myriad of opportunities, and what we really want you to be able to do is have the opportunity to practice your interests and gain practical skills, and help you be able to tell potential employers or graduate schools why your experiences are important, how they relate to the opportunity you're pursuing, and what else you'll bring to that opportunity due to these experiences. And lastly, I'd like to discuss with you an important component of the College of Science experience, which is research. More than 65% of College of Science graduates do research, and of those 65%, 73% do more than 2 semesters of research. And you also may have the opportunity to get paid for research, with 65% of undergraduate researchers receiving pay for their time. There's an incredible amount of research opportunities at the College of Science, and that more than 90% of our students could partake in research during their time here if they wanted to. Some of the great areas of research that our students are partaking in are focusing on different types of cancer, ALS or Lou Gehrig's disease, Parkinson's disease. We have students who study how job loss affects different people, as well as studying people's different relationship types and how they form, participate, and cope with the relationships in their lives. Those are just a couple of examples, but the research opportunities here are far and wide. The College of Science actually receives more funding for research than athletics has funds for all of its athletic programs. So we have an incredible amount of funding for incredible research being done by world-class faculty that our students can partake in. So thank you very much for taking the time to watch this presentation. Please feel free to reach out to myself, Colin Stout, or Aaron Deely if you have any questions. So we look forward to hearing from you. Bear down.